All right, this is Utah Middle School Math Project 1.2b, solving multi-step linear equations. This one is called putting it all together. It's called putting it all together because I want you to understand everything that we have done up to this point and how it leads to this. When we very first started this unit, way back at the beginning of the year, we had expressions that we were simplifying. You're going to see that this equation is made up with an expression equal to another expression. This expression needs to be simplified, so we're putting that together. Once we have this expression simplified, we also probably need to check to see if the other expression on the other side of the equal sign is simplified. If not, simplify that. Then, in our last lesson, we realized equations could have variables on both sides, and that's where we're going to be. But we can easily handle that by subtracting those variables from one side, balancing it, subtracting it from the other side, and then we have a two-step equation, which is also something that we reviewed many weeks ago. So all of those things that we've been practicing, solving equations, simplifying expressions, solving equations even when we have to simplify first, solving equations even when there's variables on both sides, it's all coming together in this lesson, where all of those things we practiced are right here. So we have this model of the equation 5x plus 2 plus x is equal to 4x plus 8. It says create the model with your tiles. It's already created, but we need to show what those solving steps are going to be. And the key thing is, before we can solve, we do need to simplify. You can see not only do we have variables on both sides, but on this side of the equation, we have variables in multiple places, which means this side of that equation is an expression that needs to be simplified. You can see that we've got 5x tiles and another x tile. So the first thing that we would do is probably combine those x tiles. 5x tiles plus another x tile means that when I push them together, I have a total of 6 tiles all in one place. Plus those 2 unit tiles, which is now equal to and balanced with on the other side, we have our 4x tiles and our 8 unit tiles. And now with one single step where we simplified this left-hand side, we now have an equation that looks a lot like what we did in our last lesson, where now we can start moving the variable so that instead of a variable on each side of the equation, we can limit ourselves to just one variable. And what that's going to look like both with our models and with our algebraic solving steps, I'm going to get rid of these 4x tiles. And as long as I get rid of these 4x tiles on each side, the equation remains balanced. Those are all gone now. And now we can see that that's 2x tiles plus 2 unit tiles equals 8 unit tiles. From there, the model is probably not the best way to continue. We can, but I also want to jump to those solving steps algebraically. What we could do next is get rid of these 2 positive unit tiles, balance it by getting rid of those 2 positive unit tiles on the other side, and then for sure it's better to move to the algebraic model. So again, let's look at what we did so far. We first combined our x tiles. We move those x tiles over here with these ones, giving us a total of 6 x tiles, plus the 2 unit tiles, which was equal to and balanced with, on the other side, 4 x tiles and 8 unit tiles. Although you can subtract the unit tiles from each side first, I really like having x in only one place, which is why when I have an x on each side, I try and figure out the best way to make it so I have x on only one side. We could have subtracted 6 x tiles here, but there weren't enough, so that means I'd go into the negatives. That's why I like to subtract the 4 x tiles, because I do have enough over here. So when I take away those 4 x tiles, it leaves me with 2 x tiles, plus 2 unit tiles on the left side, which is equal to and balanced with these zeroed out. So I have those 8 unit tiles. Bringing that same equation up here so that I can continue to solve, showing all of those steps. The next step that I took was I had those 2 unit tiles on each side, so I went ahead and subtracted those and balanced it. So I have 2x, which is equal to those 6 unit tiles. We group those x tiles into 2 separate groups, so I group these 6 unit tiles into 2 separate groups, or in other words, we divide each side by 2 And that's how I get x is equal to 3. Verify the solution. Something that we struggled with on our test. Verify the solution. Take the answer that we got and plug it back into the original, not the simplified. If you plug it into the simplified version, then you're never going to catch a mistake that you may have made in the simplifying process. So plug it back into the original, which means 5x is 5 times 3 plus 2 plus x, which really means plus another 3. That should be equal to and balanced with the 4x, which is now 4 times 3 plus 8. And again, you can use your calculators. Sometimes I feel like using your calculators might be more work than just doing the math mentally. 5 times 3 is 15, plus 2 plus 3. Is that equal to 4 times 3, which is 12, plus 8? And I can see both of those sides equal 20, so I have verified the solution. It does check out. And now I want you to talk with your groups about how number 1 is similar, but also slightly different than number 2. What is different here? What do we need to do? Talk with your groups and see if you can figure out what those solving steps are going to be. Pause the recording, give yourselves enough time to think. Ready, set, go. All right, what do you notice on the second one, especially as it relates to the first one? What are some things that you see? Emery? Yeah, there's groups on the second one. So yes, we still have some stuff going on here that we need to simplify, but now on the right-hand side, we have groups, which means I have to simplify. I think I said right-hand side before when I meant left-hand side. We have to simplify the left-hand side, but we also have to simplify the right-hand side because we have groups. So again, it shouldn't really change how we're looking at these. We just have an expression that we simplify, an expression that we simplify, and then we realize that they're equal to each other. Then we can begin the solving process. But we want to make sure that we simplify first before we solve. So what are those solving steps, or excuse me, what are those simplifying steps going to look like? How do I simplify this left-hand side? This is the part where you raise your hands. Thank you, Timothy. Yeah, we have some zero pairs. I have a positive and a negative, positive and a negative, positive, negative, positive, negative, where you have some zero pairs. And it looks like taking care of those zero pairs, moving those negatives over here to join the positives and realizing we've got zero pairs, that completely simplifies the left-hand side. It leaves me with 1, 2, 3 x tiles and 9 positive unit tiles. And the right-hand side, how do I simplify this? Seth? Exactly. So if we're not even looking at the model, if we're just looking at this, we see that we have 2 groups of x, which is 2x, and 2 groups of 5, which, as you said, is 2 times 5, and 10. That equals 10. Exactly. So where we have the models, we can still make it visual. We have our 2x tiles, and we have our 10 unit tiles looking across the groups. That's exactly right. And so with that in mind, let's move on to those solving steps. Remember, we are combining these positives with these negatives. And I know that it says minus 4x, but I'm thinking of them as negatives because I always change that subtraction to adding a negative. So then, when I combine those like terms, I can see those zero pairs. 7x and negative 4x combine to be 3x. Plus 9. Which is equal to and balanced with, on the other side, as Seth pointed out, 2 groups of x is 2x, or 2 times x is 2x, and 2 groups of 5, or 2 times 5, is 10. From here, like I have said before, I like to take care of those x's first. I don't like having x in multiple places. So if we want to look at that model, that would be removing these 2 x tiles and balancing it by removing 2 x tiles from the other side. Mathematically, or algebraically, that's subtracting 2x. That's going to zero out here. Balancing it by subtracting 2x from the other side. Notice where I'm writing it to. Is it okay to show that I'm subtracting 2x right here? Technically, yes, because I'm showing that I'm subtracting it from this side. However, can you take 2x from 9? No, and that's why I think it makes more sense to show that I'm subtracting 2x from this side, but I'm putting it underneath where the x's are, so it's more clear that it's the 3x's minus the 2x's. And that leaves me with 1 x tile plus the 9 unit tiles, which is equal to and balanced with the 10 unit tiles over here. And again, from that point, we can then see we should probably get rid of these 9 unit tiles, and I'm going to get rid of 9 unit tiles here. Algebraically, we're subtracting 9, balancing it by doing the same thing to the other side. That leaves me with x is equal to 10 minus 9 is 1. I'm going to pause the recording because I want students to summarize everything that they just saw. Put it all together, just like the lesson says. This is putting it all together. So put it all together. Summarize all the things that we did, all of the steps, and the order that we took each of those steps. Summarize with your groups. Ready, set, go. Okay, what happened? Summarize all the things that we saw in this problem. What did you see? Good. Charlie? Yeah, that's a brief but pretty accurate summary. We're taking care of our groups. We're taking care of 0 pairs. In other words, we're simplifying each side. Once each side is simplified, then it's just solving, which now does include moving some x's around. And now you get to practice with these ones. Says to model, and then solve. Modeling helps us see if we need to simplify or not, because we're going to see groupings or we're going to see x's in multiple places on the same side. So I do encourage models for these problems. I'm going to pause the recording long enough to get models set up, and then we can use the models to solve these equations. All right, here are all of my models. So now I can use those models to start solving. And I can see on number 3 on the left-hand side, I have groups. So I need to look beyond the groups and count up how many x tiles and how many unit tiles. In other words, I'm simplifying. 2 groups of x is 2x. And 2 groups of 3, or 2 times 3 is 6. So 2x plus 6, which is equal to and balanced with on the other side. I did not need to simplify, so I still have those 5x tiles minus 3 or plus a negative 3. So now, when I'm looking at this and I'm saying I need to move the x's to just one side, I could take away 5x tiles here, but then I'm going to end up with negatives because I don't have enough. So instead, I am going to make the choice to subtract 2x tiles from here, which I know is uncomfortable. A lot of you guys like that x to be on the left-hand side, but honestly, it doesn't matter. These ones zero out, and it leaves me with 6, which is equal to 3x tiles minus 3. We can then add 3 to each side. And this is the one reason why I don't like the models. It makes it so I just don't have enough space to do all of the other work. When I add 3 to each side, it does leave me with 9 unit tiles. 9 equals this zeroed out, and I have 3x. We can then divide each side by 3 with what little tiny space I have, and I have x is equal to 3 for number 3. And for number 4, I needed to simplify my model so I had enough space, but I hope that you can see these 2 negatives are going to zero out these 2 positives. So that's that first step, is combining those like terms. On the left-hand side, we do need to simplify first. In doing that, it leaves me with 6x tiles plus 3, which is equal to 3x tiles plus 12. I'm going to go ahead and get rid of these 3, balancing it by getting rid of 3 from the other side. So subtract 3x from each side. And again, look at where I'm showing that work. Since I'm taking away 3x from this whole side, I'm showing that I'm taking it away from the x's. Because yes, I'm taking it from the whole side, but I can only combine x's with x's. So I really can only take away the x's from the x's. 6x's minus 3 of the x's leaves me with 3x left. Plus 3 equals 12. And now this looks a lot like our 2-step equations of old. Subtract 3 from each side. We get 3x is equal to 9, which means when I divide each side by 3, I am left with, as usual, the same answer as before, x equals 3. Number 5 is where we did have to simplify both sides. The left-hand side, we had like terms that needed to be combined and then zeroed out. And we had groupings that we needed to look across those groupings. So just focusing on one side at a time. On the left-hand side, when I look at these and I create my 0 pairs, I can see that I'm left with 7 x tiles left. 7x plus 2, which is equal to and balanced with. Now it's time to worry about this other side. This other side, as I'm simplifying, I can see I'm looking across the groups. 3 groups of 2x tiles, or 3 times 2x, is 6x tiles. And 3 groups of 2, or 3 times 2, is 6 unit tiles. Gonna go ahead and get rid of these 6x tiles, balance it by getting rid of 6x tiles on the other side. And that leaves me with, algebraically, subtract 6x, subtract 6x. I'm left with just one single x tile on the left-hand side. X plus 2 is equal to 6. I could put 1x, but we've talked about that before. Lazy mathematicians just say x. It's the same as 1x. X is by itself now that I've subtracted the 2 from each side. X is equal to 4 this time. Questions, comments, concerns, anything you want to address? Okay, for number 6, it's now you writing the model, or you writing the equation. The model is given. Now you get to write what that equation is that is represented by the model. You guys, many of you have already worked ahead, so raise your hand to tell me what that equation is. Thank you, Danielle. Good. One small change that we need to make to that. 2 groups of 2x plus 3. What change would you make, Peyton? It would have to be plus what or minus what? Very good, yes. So it is 2 unit tiles, but those unit tiles are gray. So I like how you gave us options. We can say plus a negative 2, or we can say minus 2. Nicely done. And that's a good fix there. And now that we have that modeled, or we have it written symbolically or abstractly, now we can solve it. And I hope that you can see what those solving steps are going to be. We have to simplify this first. We have to get them out of the groups. Then we have to combine like terms. Here we just have to get them out of the groups. And then we can start solving. So this is a lot of steps. And this is why I have encouraged you to show your work in that specific way so that you can not lose track of where you're at in the whole process. 3 groups of x is 3x. And I'm subtracting, so I kept it subtraction. 3 groups of 2 is 6. Notice what I did there. I didn't change it to adding a negative, but I did keep the subtraction. Plus a negative x is equal to, since I took one simplifying step on the left-hand side, I'm going to go ahead and take one simplifying step on the right-hand side. You can simplify this one all the way down if you want, but since I'm lazy and don't want to take up a whole bunch of space, I'm going to try and do one simplifying step here as well. So I have 2 groups of 2x, which means I have 4x, and 2 groups of 3, which means I have 6. And I can't quite start solving yet because, like I mentioned, we've got some like terms that we need to combine over here on the left. 3x tiles and a negative x tile, that's going to combine to give me 2x tiles. Minus 6, which is equal to and balanced with the 4x plus 6. And now we're going to zero out these x tiles. I'm going to remove 2 x tiles. That way I no longer have x tiles on the left-hand side, but I'm balancing it by taking away 2 x tiles from the right-hand side as well. Be careful here. We're not just left with 6, we are left with a negative 6. Math Practice 6, attend to precision. I know we got rid of everything else that we were subtracting the 6 from, but that means that I have negative 6 left. 4x take away 2x is 2x plus 6. Again, make sure you're careful here with your Math Practice 6. When I'm subtracting 6 from each side, it zeroes out here, and negative 6 minus 6 more is negative 12, which is equal to 2x. Divide each side by 2, and that's how I get negative 6 is equal to x. How'd you guys do? All right, so the next is just a lot of practice. Says without the use of tiles, because at this point, continuing to use models is going to be rather tedious. So I hope that you have found ways that you can do this without needing those tiles. It's still okay to visualize tiles. When you visualize what it would look like, it does give you clues as to how we need to simplify it. But it is getting to be too long to continue to draw models for each of these problems. So I want you to work through as many of these as you can in the time that we have. Notice that they do start getting to be a little bit crazy. So I want you to work through as many as you can in 7 through 12. And then we'll go over a few, but I also want to make sure that we have time to go over some of these ones, 13 through 16. So pause the recording, give yourself an opportunity to work through as many of these as you can so that we can just check our answers when we come back. Pause the recording now. All right, we're checking our answers for all the ones that we've completed. Pause the recording if you need to see them for a little bit longer to check your answers. If you got the wrong answer, check your work against mine, see if you can find where you've made a mistake. Sorry, too far. All right, and now let's look at 13. Do we really need to be concerned about 13? We're just distributing a 1/4. So we're thinking of, if I had this in a group, what is 1/4 of that group? Or in other words, what's 1/4 of 12? What's 1/4 times 12? X. That's just going to be 3x. Plus, what's 1/4 of 16? Or 1/4 times 16? It's just 4. Just because it's a fraction doesn't mean we need to be concerned. In fact, the part you need to be concerned about is honestly this part. I'm going to rewrite that subtraction to be adding a negative. Because what I'm seeing is I'm distributing a -3 across negatives or across subtraction. That gets to be a little bit messy. That's where I'm probably going to make mistakes. Not where the fraction is, but all this other stuff. We can't do 10 plus a -3, as you're probably tempted to do, because that -3 is showing that we have -3 groups of this. So -3 groups of x is -3x. -3 groups of a -2, or -3 times -2 is a +6. I took care of the grouping symbols, but don't forget we still have our 10 units at the beginning. Still not making any changes to the left-hand side. That's already simplified, but now I can combine like terms, 10 and 6, which combine to 16. And now that's really not so bad, is it? This time I'm going to zero out the -3x by adding 3x. When I add 3x to the -3x, it zeroes out, and it avoids negatives because 3x plus 3x is going to be a +6x. Nice and easy now. We subtract 4 from each side, giving me 6x is equal to 12. I can divide each side by 6 and get x is equal to 2. Now, I do like 14. 14 gets to be a little bit interesting. There's a couple ways that we can handle 14. One way is recognizing what's happening to x on the left-hand side. It's first multiplied by 2, then subtracted by 9, and then divided by 3. So we can take the 2x, divide it by 3, and the -9 and divide it by 3. That would work. But one of the ways that I like handling this the very best, because this just looks different than all the other ones that we've done so far, make it look the same. How do I undo that dividing by 3? Multiply by 3. So I'm going to multiply the whole side by 3. Well, the whole side was divided by 3, so now that whole side multiplied by 3, that divides out, or multiplies out. But what do we need to do to the other side? Multiply the whole side by 3. How do I multiply the whole side by 3? Put it in parentheses and multiply the whole thing by 3. Let that sink in. It is okay to undo this by multiplying by 3 because I am multiplying the whole side by 3. I'm also multiplying this whole side by 3. You've heard me say it before, whatever you do to one side, you do to the other side. But we just need to make sure that we're emphasizing we're doing it to the whole entire side. This now leaves me with, on the left-hand side, 2x minus 9, which is equal to, we can simplify this. We can keep it in groups if we need to, but we also have the power. 3 groups of 8 is 24. And 3 groups of a negative 3x, or subtracting 3x, is going to be subtracting 9x. Now that's nice and easy. Not too bad. Plus 9x from each side, because I don't want to have to deal with any negatives. Negative 9x plus 9x zeroes out. 11x minus 9 equals 24. Add 9 to each side. And I have 11x is equal to 24 plus 9. It's 33. Divide each side by 11, and we get x is equal to 3. 15 is the last one that I want to go over. There's lots of ways that you can handle it. I just want to show you another way to think about this. Y divided by 3 is basically 1/3 of y, right? We're taking y, we're splitting it into 3. Just like if I had 1/3 of y. So with that understanding, I can rewrite this just so it looks a little bit more comfortable. Instead of y divided by 3, I can write it as 1/3 y plus 5 is equal to, same thing over here, y divided by 2. How am I going to rewrite that? 1/2 y plus 3. So now, when it's time, and I want to move these y's to the same side, if I subtract 1/3 of a y, it's going to be gone from this side. So I can then subtract 1/3 of a y from here. And you have calculators, so you don't even need to be worried about that. 1/2 of a y minus 1/3 of a y is equal to, nobody? 1/6 of a y. You were getting there, I know. I'm moving fast. Subtract 3 from each side. Gives us 2 is equal to 1/6 of a y. Now, lots of ways you can do this too. How can I undo multiplying by 1/6? We can divide. But also, I hope you're feeling comfortable with fractions to know if I just had 6 of these, isn't that going to undo the 1/6? That's a lot easier for me to do in my head. 6 times 2 is 12. 16 you're going to have to save for your own. Here's your homework. 1.2b. I'm going to let you skip 4, 5. You can skip 5. I'll let you skip 5. But please remember, 5 problems. Look at 8 through 16. Which types of problems do you think are most likely to be on a test? Problems like 8 through 16 or easy problems like 2 through 7? Yeah, so should we be skipping the hardest ones? Okay, skip them and then get them wrong on the test. It's fine with me. It's time to get cleaned up. Thank you for watching the video. We'll see you next time.